Assalamu alaikum. Mostly students find uncertainty quite difficult, so I thought let's make a video on it. So the question for uncertainty is usually question number one, and it usually starts with a definition. There is one trick that I always say that we all should follow. Okay, you have to remember as a student that it's all connected. Like whatever they are going to ask you in the first part, they are going to utilize it in the second part, and this is all connected, and all the parts of the questions are connected. Let's suppose the first question they're asking you over here is they're saying define pressure. When they say define pressure, the simplest definition that you have for pressure is you will write force per unit area. That's it. You don't have to write anything else. That's it. You just write force per unit area. Now in the second part, they are saying a cylinder is placed on a horizontal surface as shown in the figure. The following measurements were made on the cylinder. Mass is given in kilograms and the diameter is given in centimeters with the absolute uncertainties. They are asking you calculate the pressure produced by the cylinder of the surface. Now I told you it's all connected, right? तो उन्होंने first part में they asked you for the definition and now they are asking you for the calculation. So you will write pressure is equals to force per unit area. Now here in this case, the force is basically the weight that is acting downwards, okay? And the area is this circular area that is here. So the area for a circle is pi r square, and since I've been given diameter, so what I'm going to do is I'll put d by 2 in place of r and I'll get pi d square over 4. So the formula that I am going to get over here is, for me, force is equals to weight. So the pressure finally will be mg over pi d square by 4. Okay. Now P is equals to 4 into mass is 5.09 into 9.81 divided by, and pi d 9.4. Since this unit is Pascal and here it is centimeter, so I should put 9.4 exponent minus 2 square. So when I'll put these values, I'll get the answer here, which is 4 into 5.09 into 9.81 by pi into 9.4 exponent minus 2 square. So my answer that I'm getting is 7195.17 pascals. But my one more important thing that I have to follow here is I have to look at for the significant figures. So since the least significant figures here are 2, so I'll try to answer this in 2 significant figures, and it's going to be 7200 pascals. Okay. Now they're saying calculate the actual uncertainty in the pressure. The pressure formula is using mass and d square. D is squared. For actual uncertainty, the first thing that I need to do is, because this is a formula where division is here, so I cannot solve it by adding the absolute uncertainties. I need to find the percentage uncertainty. So for mass, what I'm going to do, 0.01 divided by 5.09 into 100. Okay, so when I'll do this, 0.01 by 5.09 into 100, I'm getting, 0.01 by 5.09 into 100, so I'm getting 0.196%. And for diameter, I'll get 0.1 divided by 9.4 into 100. So 0.1 by 9.4 into 100, I am getting 1.06%. Okay, so percentage uncertainty in pressure will become percentage uncertainty in mass plus 2 times percentage uncertainty in diameter. 0.196 plus 2 times 1.06%. So I'll get into 2 plus 0.196, so I'll get 2.32%. This is percentage uncertainty in P. And from here I'll get absolute uncertainty by dividing this value by 100 and multiplying it with this 7200. So when I'll do this, divided by 100 into 7200, I'm getting 167.3, or I can round it off to 170 pascals. And then the answer, because I wrote 170, so I can write it as 207.2 exponent 3 pascals. So this is how you solve the uncertainty for a question.